Welcome students. Today our lecture is on topic of instruction format. So these are the our contents of our today lectures: instruction formats, type of address instruction. So there are basically three types of the address instructions: three address instruction, two address instruction, one address instruction, and zero address instruction, and last is data transfer and manipulation. So what is the instruction format? When the assembler processes an instruction, it converts the instruction format, its mnemonics form, to a standard machine language format that is known as an instruction format. An instruction format defines basically the layouts of bits of an instruction in terms of its constituent parts. An instruction format must include an opcode and implicitly or explicitly zero or more operands. So, an instruction format basically used to define a layout of bits used in an instruction. These are the graphical notations which are used to denote an instruction format. Basically, when we represent any instruction, then mostly instruction have two parts. So one part is known as an opcode and second part is known as a operand. This operand is also classified one and more sections. Basically, opcodes are used to denote what operation we have to perform data stored in operand. There is another way of representing instruction format. First one is opcode, second one is mode, and third is address or operand field. This opcode is used to denote the operations, and this mode basically introduces that in which mode we have to operate. It means like as a direct addressing mode or indirect addressing mode. Now, there are basically three types of address instructions. First one, three address instruction. Second one, two address instruction. And third one is one address instruction. And last and final is zero address instruction. Now, what is the three address instruction? Basically, all instructions which have three parameter, or in other words, we can say use the three storage components or elements are known as a three address instruction format. For example, we take here add is denoted as a three address instruction because it performs this operation using the three registers R1, R2 and R3. So he want to perform the addition, so he used three registers R1, R2 and R3. So contents of R1 plus R2 is replaced in register R1. So due to this reason, this instruction is known as a three address instruction. Now, another familiar example of three address instruction format is here. We take an expression x equals to a plus b multiply c plus d. So, to perform this instruction, or in other words, to perform this expression, we have to use the three address instruction format. First one is we are taking move. This instruction basically used to move the contents of a register or memory locations to a register. So here we are using three operation element like R1, A and B. So the contents of memory location A and B are stored one by one in register R1. Another is add R2, C or D. So the contents of memory location C and D are added and then replaced in register R2. And similarly, we use the three address instruction multiplication that is denoted by the mul x r1 r2. It denotes the multiplications of r1 and r2 is performed and result is transferred in x. So basically 3 address instruction needs very long word to hold the everything. The advantage of 3 address for instruction format is that it results in short. The disadvantage is the binary code instruction require too many bits to specify. Now, next is two address instruction. Of the address instruction which are performed in two elements or two storage components, like they may be both memory locations or one memory location and one registers. Such type of the address instruction is known as a two address instruction. Now, we again use this familiar example x equals to a plus b multiply c plus d, and we have to perform this expression using the two address instruction. So, we use move. The move in the three address instruction behave like as a three address instruction, and move again here will work like as a two address instruction because we use here two parameter r1 and a. So using the a, the contents of memory location a is moved into the register r1. Then we use another instruction add r1b, that is also two address instructions. So it performs the contents of memory locations b plus contents of register R1 and again replace it in register R1. Now, to perform C plus D, we again use the move instruction and we take the memory location contents of memory location C and replace in register R2, and using the add R2D, we take the content of the memory location D and add it with register R2, and result is again replaced into the register R2. So that is the two address add instruction. Again we have to perform the contents of R1 multiplied by R2 and have to replace in R1. So using for this we use the two address instruction mul R1 R2, and we multiply R1 with R2 and result is again replaced in R1. Last and finally, we have to put the overall result in the location X. So for that we use the instruction move and X R1. It means contents of register R1 is moved at the memory location X. So there are some comments on the two address instructions. First one is it reduces the length of the instructions. Second, move instructions move on the transfer the operand to and from the memory and processor registers. Next one is one address instruction. So one address instructions are those type of instructions which are performed only a single storage element, and basically these type of instructions are performed using the accumulator register, and this accumulator register is also considered like as a processor register. Now using the one address instruction we have to again perform this expression x equals to a plus b and whole multiply by c plus d. So first using the one address instruction we have to load the memory contents of a into the accumulator register. Again we have to add a plus b. So to perform it we basically add the contents of C plus memory location of B, and result is transferred into the accumulator register, and again we have to perform C plus D. So we have to store, or in other words we can say we have to release the accumulator register. So due to this reason we basically store the accumulator data at a storage or temporary storage T. So the contents of accumulator is transferred into the memory location at memory location T, and again we perform C plus D. So we use the one address instruction load C. Using this instruction, basically memory location contents of memory location C is transferred into the accumulator register, and we perform the add operation and add with D. So accumulator contents are added with the memory location of D, and result is again transferred into the accumulator register. Now again we have to multiply A plus all addition of A plus B by the all addition of multiply with the all addition of C plus D. So we have to release again accumulator. So to perform it we have to use another temporary memory location that is known as a mult T, and contents of these are stored here. Now again we have to put our R regent at the memory location X. So we have to here transfer the overall result of accumulator into the memory location of X. So there are again some comments on the one address instruction. First one, in this all the operations are done between the accumulator register and memory operand. T is the address of temporary memory location for storing immediate results. Now, next one is zero address instruction. So, those instructions in which all addresses implicitly added in the instruction itself is known as a zero address instruction. So, all addresses implicitly like as a add, and basically in such type of the operation we use the stack operations push and pop. For example, we have to perform this expression again using the zero address instruction. So, using the zero address instruction, we use some implicit instructions like as a push, pop, add, multiply and pop. So, to perform it, first we have push A. So, using this instruction push A, the TOC, that is denote the top of the stack. So, using the push A instruction, the top of stack hold the value of A, and again when we perform the push B operation, then TOC increase the value and denote the element B. As we perform the add operation, then TOC basically denote the addition of A plus B. In other words, TOC basically denote the sum of A plus B. And when we use the push C operation, then TOC denote the C. Push D operation, TOC denote the D. And when we perform the add operation, then basically TOC denote the result of A plus B. And finally, when we use the mul operation, then in mul operation or multiply operation, then TOC basically denote the overall multiplication of A plus B and C plus D. Finally, overall result is held by the TOS element, and this result we have to store the memory location X. So, using this we perform basically pop operation, or we pop instruction, and pop X. Using this instruction, basically contents of the TOC is transferred into the memory location at the memory location X. So, using the zero address instruction we also can perform the given familiar expression. Now, our next topic is data transfer and manipulation. So, basically, we know that the computers provide an extensive set of instructions to give the user flexibility to carry out the various computational tasks. So, any computational task is performed in the computer, then we have to perform the various type of the moments and carryouts. The instruction sets of the different computer differ from each other mostly in the way of operands are determined from address and mode fields. So we know that every computer have the different architecture. So due to this reason there are different types of the address mode bits. Now, data transfer and manipulation. Basically, there are three types of the data transfer, or in other words, we can say that generally computer instruction can be classified into three categories. First one, a data transfer instruction. Second, data manipulation instruction, and third is data control instruction. So, what is data transfer instruction? Data transfer instructions goes of data from one location to another location without changing the binary information content. And in other words, these type of data are used to transfer the binary information from one palace to the another palace. So there are examples of data transfer instruction like as a load, store, move, exchange, input, puts, push, pop. These are those type of instruction in which when data is transferred from one location to the another locations, then there is no any change in the binary information content. It means there is no any change in the sequence and there is no any losses of the bit. Next, data manipulation instructions. Data manipulation instructions are those that perform arithmetic logic shift operation. Basically, data manipulation instruction in typical computer usually divided in three basis steps. First one, arithmetic instruction. Second, logical and bit manipulation instruction, and third is shift instruction. So there are some examples of arithmetic instructions: increment, decrement, add, subtract, multiply, divide, add with carry, subtract with borrow, negate. It means taking two's complements. These are the examples of the arithmetic instruction. Now, second, next is logical and bit manipulation instructions. These are those instructions which are basically used for the logical operations like as a clear, complement operations performed like as a AND or exclusive or clear clarity, set carry, complement carry, enable interrupt, disable interrupt. These are the examples of logical and bit manipulation instructions. Is shift instruction. These are those types of the instructions which are logically shift either left or right. For example, logical shift right, that is represented by SHR, logical shift left, that is represented by the SHL, and arithmetic shift right, arithmetic shift left, rotate right, rotate left, rotate right through carry, rotate left through carry. These are the examples of the shift instruction. Next one is program control instruction. The program control instruction are the machine code that are used by the machine or in assembly language by the user to command the processor act accordingly. For example, branch, jump, skip, call, return, compare by subtraction, or test. So these instructions are performed or by the processor, or we can say these are the commanded to the processor act according their action. Branch instructions are used to move, selecting the appropriate branch. Skip jump instructions are used to jump at specific locations, and so on. Thank you.